The purpose of this video is for you to be able to implement percent errors meaning towards data and conclusion. And by implement, I mean use with understanding. Now, someone's pulse is to their heart health as percent error is to data quality. So let's say Dr. Square measures Crazy's hair heart rate, and he gets 65 beats per minute. That means, hey, your heart is fine. And then he measures Professor Triangle's heart rate, and it's 200 beats per minute, so they say call 911. A similar scenario exists for percent error and data quality. Now, this is what percent error means about your data and your conclusion. And now, if I've got percent error values that are high, and the range of these values is greater than 15%, what that means is your data is inaccurate and invalid, and any conclusion that you're going to make has got a large source of error, and that this provides weak support for any theories that you're going to base on your data. Now, however, there are a low set of percent error values with a value range from 15 to 5%, and this means you've got pretty accurate data and pretty valid data, and you've got moderate source of error and a moderate support for your theory. Now, the final range, you get really low values. This is between 0 and 5%. That's what we want. This means you've got really accurate and valid data, and you've got a small source of error, and you've got strong support for whatever theory that you're going to generate based upon the data. Now, one thing to keep in mind is based upon your scenarios, these values or ranges are going to change, and their implications are going to change. For example, let's say you wanted to send a rocket to the moon, and your percent error values were 3.2%. Now, that's really low. However, if you're sending a rocket to the moon, you really can't, the margin of error, even this margin of error, is too big. So you'd have to do some more tests to get those values back where you want them to be. And on the flip side, if you're cooking an omelet, and let's say it calls for a tablespoon of pepper and you add a tablespoon and a half, that would give you 50% error. And it's not going to matter that much. The omelet probably will be just fine, regardless of this is a really big error value. So these ranges outlined in the table above really apply to the scenarios. And one final thing, even though you've got a low percent error, it doesn't mean you've got a strong theory. For example, let's say you're studying an unknown liquid, and you're like, hey, my percent error value was 2%. I think it was water. But however, it's rubbing alcohol. So even though you've got a low percent error, you still have to interpret the data in the correct manner and arrive at the right conclusion. So even you could still make a mistake with low percent error values.